To all of you joining me for this video, I hope everyone's doing well. I'm Mr. Ish. We are looking here at a triangular pyramid volume exercise. It is a result of an inquiry from a viewer. The question was this: if I'm given the S, I'm given the H, how can I find the volume of a triangular pyramid? Before we talk about the S and the H, consider this important aspect. I have here a triangular pyramid which looks like this. The question you need to ask is, what type of triangular pyramid is it? If I look here at a cross-sectional slice and I pluck it out and my slices are equilateral triangle in all respects from the base to the apex, then that's one specific scenario. But I could have a situation where I have something which looks like this. These two sides are equal, but that side is unequal. It's a different dimension. I can have a situation which looks something like this. This side is not equal to that, which is not equal to that. Now consider these two items. I have this as one scenario and I have this as one scenario. If I'm given just an S and an H, then this is what we're really talking about, because given the S, it suffices and you can easily determine the volume. If I'm looking at this situation, then this right here is missing an information and I still need the height of this triangle that you're looking over here. These triangles, I must still have the height of it. And which triangles are we really focusing on? Not cross-sectional slices. You're focusing here on the base triangle, because that is what is the main triangle which will determine your volume. In this particular scenario where the slices are always equilateral triangle, two pieces of information, your S and the H, suffice. In this particular scenario, this is not enough. You need the height of your base triangle. This specific triangle, the height, we need that. If you don't have it, we're looking here at this scenario, equilateral slices all the way across, and this is what we're talking about in this video. What is S? What is H? It is the dimension of your base triangle all the way around, because it's equilateral. S. What is your height? It's the height of your pyramid from base to apex. Conveniently, S can be corresponding to the slice dimension from the base to the apex no matter what. Anyhow, now how can we determine the volume given only these two pieces of information? We know per geometry, volume of a triangular pyramid is always equal to 1 over 3 BH. What is this B? B represents the area of your base triangle. Area of your base triangle. This right here, there's a certain area to this triangle. I multiply by the height, I divide it by 3 and I have my volume. This 1 over 3 comes from calculus. How can I determine this given only S? Because I know H corresponds to the height of the pyramid. The only relevant value are the S's. Well, you can do geometry. I have S's all the way around. I'll bisect this, make two right triangles. Suddenly my base got split into halves, S over 2, S over 2, and I can easily find this height. I can do that height, we'll call it A. A square plus B square, which is S over 2 whole square, which is S square over 4, is equal to C square, which is S square. Solve for this A, which is representing the height of your base triangle. A over here is equal to 1 minus a quarter, which is a 3 over 4 S square, and then root, and you will have here a S over 2 root 3. I have S over 2 root 3 is equal to that. I can easily determine this now, the area of this base, using my half base height area formula for a triangle. It's equal to half times base, it's S's all the way around, times your height, S root 3 over 2. When you bring all of this together, you are having here an S square root 3 over 4. This right here represents your base area, which is only this component. Now let's talk about the volume. The volume is going to be 1 over 3 times that base area, which is S square root 3 over 4 times height. Bring everything together and simplify. I'll have S square H over 4 root 3, because this root 3 will simplify with that. My volume is equal to S square H divided by 4 root 3, where S represents your dimension of your base sides of that triangle. Now let's bring everything here into a convenient question. When you are given only two pieces of information, think equilateral triangular slices all the way from the base to the apex, and this formula is your formula, and as is this. If I'm given a certain side is equal to 4 and I have a height of your pyramid equal to 15, if I go through this formula, it's work, because I still need to determine the base area. But this formula works wonderfully because it already has the base area incorporated. You just plug in your values. You have here an S square, which is a 4 square 16 times your height 15 divided by 4 root 3. 4 can simplify with this, but I'll have a 4 then I'll have a 4 times 15, which is a 60 divided by root 3. But I can rationalize this, and I'll have here a 60 root 3 over 3. But when I simplify it, 3 goes in 60 20 times. My volume will be 20 root 3. So the volume of a certain triangular pyramid having a side 4, having a height of your pyramid 15 is 20 root 3, and it will be right. Obviously, you can mention the units. It'll be what are units cube. 20 root 3 will be correct. You have two formulas, 1 over 3, capital BH, but capital B still implies you have to determine the area of that base triangle, or this, which has the work already done. S squared H over 4 root 3, your base area is already figured in here, especially when your cross-sectional slices from the base to the apex are always equilateral triangles. When you're given two pieces of information, then that applies. If you have a third piece of information, then that's representing the base triangle height. So you can easily determine the base of that, then run everything through this formula right over here, 1 over 3, capital BH. Thank you for watching.